Hello class, this is Mr. Lehman. I want to talk to you today about the size of ions. Alright, so we've been talking about in our first two chem class neutral atoms. So what happens if an atom gains or loses electrons, and how does this affect the size of it? So remember, we call atoms if something is neutral, and that's because the proton number is equal and opposite to the electron number. But atoms can gain or lose electrons, and so we use the word ions for things that are not neutral, and these are things that do not have an equal number of protons and electrons, because electrons have either been lost or gained through chemical reactions. Alright, so let's take a look at what happens if something gains an electron and what happens if something loses an electron. How does that make them bigger or smaller? How does that affect their size? So here we go. Alright, so let's take a look at, we'll go magnesium. Magnesium has 12 protons and 12 electrons, and so magnesium has 2 electrons in the first energy level, 1s2, 8 in the second energy level, 2s2, 2p6, and then it has 2 on the outside as 3s2, third energy level, third shell. And so I like to go ahead and I like to talk about the effect of nuclear charge again, figure out what's happening here within this atom. And so remember, each inside electron, each core electron, in this case the first and second level, can block out, can shield the outer electrons from a positive charge. So if we had 10 inside electrons, 10 core electrons, they're going to shield the outer electrons from 10 of the 12 positive charge. And that leaves effective nuclear charge of 2+. So the 2 valence electrons are going to be pulled in with a +2 charge to the nucleus. Alright, so that's just pretty small. Right? That's not a big force. And so what we can see here is magnesium is going to have these 2 electrons, the 2 valence electrons, taken away from it, ripped off by other elements that have higher electronegativities, and that's a word we'll talk about later this unit. And so what will magnesium look like after it loses 2 electrons? Alright, so now we still have 12 protons, but we only have 10 electrons left because the 2 and the 3s were ripped off. So let's go ahead and draw this. That's my nucleus. And so there's only 10 electrons left. Then we have a configuration just like noble gas neon. 1s2, 2s2, 2p6. Magnesium that has a positive 2 charge is very, very, very stable. It's really, really hard. It takes a tremendous amount of energy to try to steal any more electrons from it. And let's see, why is that? So we have 12 positive charges in the nucleus, 12 protons. There's 2 core electrons. These 2 electrons will shield the outer valence electrons from 2 of the 12 positive charge. And so that leaves an effective nuclear charge of 10. Alright, so there's a 10 plus positive charge pulling in these valence electrons. And so that's a very, very strong force compared to this 2 plus force. So not only does it have 1 fewer shell of electrons, it only has 2 shells, which makes the electrons closer automatically, but it's pulling them in with roughly 5 times more force. And so that is going to result in an even smaller ion. So yes, it has 1 fewer subshells, or 1 fewer shells, but then it's also being pulled in with over 5 times more force. And so what we're going to see is that positive ions always are smaller than their neutral counterparts. So as atoms lose electrons, they will become smaller, and usually much, much smaller. Now what happens if an atom steals an electron? So let's look at oxygen. Oxygen has 8 protons and 8 electrons. And so let me draw in the proton number, be consistent. So 8 protons, so we know it's oxygen. It's in period 2, so we know there's 2 shells of electrons. We know the first shell can only hold 2 electrons, 1s2, and that leaves 6 electrons, 2s2, 2p4 for the second shell. 8 positive charge, the 2 inner electrons, the 2 core electrons, shield 2 of the 8 positive charge from reaching the valence electrons. That leaves a positive 6 effective nuclear charge to pull in the outer electrons. That's a strong force. What oxygen wants to do? Oxygen wants to steal 2 electrons. Oxygen wants to steal 2 electrons from other atoms. When it gets 8 on the outside, that's an octet. That'll make it very stable, like a noble gas. It wants to become like neon. And so note, we still have 2 inner electrons, 2 core electrons. We have 10 electrons total, and that's because there's now 8 valence electrons. Alright, so did the effective nuclear charge change at all? And the answer is no. There's still 8 positive charges. There's still 2 inner electrons that are going to shield. So we still have a 6 positive charge pulling in these electrons. But the problem is there's a 6 positive charge pulling in these electrons, but now there's 8 electrons to be pulled in. And so the 6 positive protons are going to have a harder time finding and pulling in those 8 electrons. And so we're going to see that as atoms steal electrons, they become larger. Alright, so negative ions, atoms that have stolen electrons, become larger. And that's because those protons in the nucleus are having a harder time seeking out and finding all those valence electrons. There's more valence electrons now trying to pull them in, so they're less effective at pulling in those electrons. Alright, so that is ion size. Hopefully this helps you, and have a great day, everybody.